Welcome, everybody, to Weekly Quantum World Detangled, Season 2, Episode 6, coming to you from around the world once again.
Everyone, Denise Ruffner, Chief Business Officer at Cambridge Quantum Computing in Pasadena, California. Still dark out, so I can't give you a weather report, but the fires are gone. And my friend Tommaso.
Hello, everyone. Good evening from Singapore. Tommaso from Entropic Labs. Also dark, so also no weather report from here, but Denise, I'm very happy to hear that the fires are finally gone. That's good. And I'll pass it back to André.
My name is André König. I'm the CEO of Interference Advisor, and today we're joined by the Brazilian fraction calling in from LA, but excited to welcome Isteluna Alves.
Hi, good morning, everyone. Isteluna Alves here from LA, a little close to Pasadena, as where Denise is. I'm excited to have this conversation today.
Good, and I'm always excited when we have people more like myself who are not true quantum experts and maybe didn't study it as much in school. And it can be a little difficult to penetrate the quantum market and the circles and people at times. And would love to hear your experience a little bit, Istelun.
Absolutely. I'm a computer scientist, not a physicist. I don't have any physics background. I started in the field when I actually went to a meetup and I fell in love with the concept, and I had the click of how that would relate to the field of study that I was researching in image processing and graphics imagery. So that click just changed everything, I would say. And then from that moment on, quantum was part of my day, like every day.
And do you struggle sometimes with the fact that you didn't study it? Is it something that people make you feel? Do you feel like a D-Wave annealer, or do you feel like a full stack IBM Honeywell quantum computer?
Over the years, I have learned what are my limitations. So I don't have expectations to create new quantum algorithms. So I focus on, or I'm best on applying quantum algorithms and making the match between quantum algorithms and classical computation. So I don't really bother about the huge struggles sometimes with the physics and all of that. I think that after you dive a little bit more into the field, you don't really feel that you are lacking on not knowing the physics behind everything.
And you're originally from Brazil. Do you have friends in Brazil that work on quantum? Do you know professors, academics, other entrepreneurs in Brazil working on quantum ideas?
Yeah, I actually made my advisor go with me into this journey of researching in quantum. I made my whole dissertation in the field, and he had no clue about quantum, and he also got excited about the idea of researching something so novel. I do get more friends. I'm the one bringing more friends into quantum computing. I'm part of small groups, and here and there I also participate on meetups, and I introduce I make an introduction to quantum computing. I know some professors that are with the physics, like in quantum mechanics. Not many quantum computing programmers, but I would say that I'm starting to see things kicking off in Brazil as well. And actually, there is a Brazilian that was part of the proof of quantum supremacy from Google, Fernando, who lives here, also Brazilian.
Good. That is a great story, and quantum is for everybody. We had Uruguay in episode 5. We have Brazil now We have Africa represented with Farai on my team. We spoke to small Southeast Asian countries. Quantum is not limited to the big, studied at MIT, live in Maryland or California, but accessible to everybody. Let's learn more about BoxCat, Denise.
So it's so great to have you on. Thank you for joining us. It's fun to have you as a neighbor, so to speak, in the LA area. Wanted to start off by having you tell our audience about BoxCat. I love what you do, and I want to hear more about it.
Sure. So I'm Brazilian, but I happen to be, I was living in Toronto. And in Toronto, probably here on the show, there was also somebody else from the same program. I joined the Creative Destruction Lab, a program that they offer in quantum machine learning in Toronto. Tries to create new startups. So in that opportunity, I was searching ideas, and I met Bryce Hunter, who's one of the co-founders of BoxCat. And we decided to go into graphics, into trying to solve problems in rendering. So BoxCat is basically a startup that researches post-production for animation films. And our main goal is to reduce the time for rendering. And on that end, we also try to find solutions for advantage in image processing, applying machine learning to image, like any sort of problem that is interesting to solve, that takes a lot of time with images.
And I think I met you at a trade show at a major film studio when your table was mobbed. So I think rendering is something that's very time consuming.
Absolutely, yeah. It's also very expensive, financially speaking. Usually, it's 1/3 of the budget for any animation film. So it's a lot of money that is thrown on this very specific problem. It's just you sit there and you wait for the image to be completed. So rendering, essentially, it's like converting a 3D model into the final image. It's just that last step where the animators, they created all the animation, and that animation is then rendered, is then translated into a final image.
And do you guys have customers that you're working with?
We have been working with studios in Brazil. Bryce Hunter is also connected with studios in Toronto, so that helped to do more research with the support of animators, the real ones that are like struggling with the issue. And here in LA, as you said, we are always trying to find new studios that are interested in learning about our solution, interested in sharing a little bit of their pain with us and how we can actually solve it. I have no audio.
Okay.
Yeah. Thanks, Ista. I'm going to hand it over to Tommaso because I can see his mind spinning with technical questions to learn a little bit more about what you're doing. So now the grilling will begin from Tommaso.
No grilling is late here. Hi, Sloan, and thanks for joining us. Very interesting to hear what you guys are working on. To be completely honest, I know very little about rendering. I mean, I know it exists. I know it's a problem. I think I have actually met you before at the Rigetti Quantum Advantage event a few months ago in Sacramento. So I remember your presentation then. We didn't really have time to talk, so maybe I can ask you a question or first question now. I'm always interested in understanding when I hear new problem statements, why people think that quantum computers could help. I don't know how simple it is to do that, but could you try to break down the fundamental reason why you think quantum computers could really help with rendering? And not necessarily in the short term, also down the line.
So specifically for rendering, there are many different types of rendering strategies. And the idea came of like, maybe we could try a totally different approach with quantum. There are different techniques, like going over every single piece of the image, or rendering by patches, rendering by areas, rendering by color, rendering with radiation techniques, how much light objects are transmitting into the scene. So there are many different ways of doing rendering. So for us, that is there is a good start, because we're not limited by just one type or one thing. So we can try different rendering techniques and see what actually get we get results in the quantum space. So we actually had some very good success doing hybrid rendering. Basically not rendering the full image on the resolution that we wanted, but starting with a smaller version of it, and then using machine learning with the support of quantum computers to go from a smaller version to a bigger version, like a higher resolution of that image. Essentially, we got an algorithm from Google that has been very successful and applied with in the Pixel phone that Google has, and it got that algorithms, and we inserted quantum algorithms, making the part that is more time consuming on that algorithm with a quantum computer. So on the long term, we see with more qubits we can deliver images that eventually would be faster than using only classical computation.
Okay, thanks. And when you talk about quantum computers, do you mean quantum annealers, or do you mean gate-based, let me say, universal quantum devices?
So we have tried essentially two major architectures. We have tried an annealer. We actually did the first image ever rendered with the support of a quantum computer using an annealer, and that didn't provide us much speed up, but it was a very, very good experimentation to see how rendering could actually be done with the support of a quantum computer. So we moved to an IBM computer, which is also the same architecture as the Rigetti, as you mentioned, that I was speaking about. And with that, we actually changed the approach of not doing the full rendering with the computer, but just doing parts of the algorithm with the quantum computer. Does that answer?
Sure, it does. Yes. And when you say doing only parts of the algorithm, I don't know if I'm thinking this right or not. Is it something like you have an image? So imagine you have an image, and you can break down the image in different parts, and then you can transfer each smaller section of the image, and, for example, process the much reduced amount of information using a quantum computer. Is this what happens, or am I thinking it completely wrong?
Yes, I just don't want to go very
of course,
technical, but essentially we get an image, and then because we can break it into smaller parts, that makes it more viable to use the quantum computer. We actually can go even lower to a lower level and process just a single pixel. And for us, that is very good. We can process all pixels in parallel if we have that potential with more qubits. But we try as much as possible, knowing how it operates. We reduce our problem to a smaller problem, but also when you consolidate all the pixels that you process, you can have images of any size, right? So in our specific problem that we had more like success. We actually just sent all, like every single pixel by, like, it's as a specific, as one single problem. So the size of the image is not really relevant. It's more you have to start with some reasonable size. When you actually consolidate everything, it makes more sense. But essentially, we are calculating distances with the computer. So those distances are input for another step on the algorithm.
Okay, got it. Thanks. I can also see that André is like impatient. He has questions to ask, so I will pass it to him. Thank you. Thanks.
Thank you, Tommaso. And Istalon, it's time for our 12-question muscle bruise quantum survey. And your challenge will be to answer somewhere in between one word and one short sentence. Just really what comes to your mind first. And it's to get to know you a little bit better, hopefully. So if you're ready, we'll proceed with the Marcel Bruce questionnaire.
So I can only say one word. I cannot defend myself.
Defend yourself. If every now and then you throw in a second, third word, we'll let that slide. But to get started, what would you say, Stellan, is the principal aspect of your personality?
Enthusiasm.
Enthusiasm. Okay, that shows. Very good. What's the quality that you desire most in an entrepreneur?
Be a little colder, like be more incisive.
Okay. Is that an issue for you?
I sometimes I have troubles negotiating, I would say. I would like to be more affirmative.
What would you say is your best virtue?
Optimism.
What is your principal flaw?
Impatience sometimes.
I know that one. What do you appreciate most about working in quantum technologies?
It's, you have all the possibilities. You can try everything.
And if not a quantum tech entrepreneur, what would you be doing most likely?
Probably something related to art or images. I love images as well.
Who's your favorite scientist?
I would say Einstein, because of the revolution that he caused.
Who's your favorite entrepreneur?
I think Elon Musk. I think the vision that he has for it's just mind-blowing sometimes.
And I'll throw this one in just for you. Who's your favorite artist?
That is a very like, I have some very good, like I'm very strong connected to some, but I would say that what I like really like is Renoir.
Renoir. Nice. What is your?
I can stop for hours in front of his paintings and just getting it all in.
What is your favorite quantum computing modality? Superconducting, photonics, topological, ions.
Yeah, superconducting.
Why?
I think it's, for me as someone that is not on the physics side, it was easier to digest and incorporate more of just classical computation and think about it more like a regular computer that has superpowers.
What is your quantum dream?
Millions of qubits. I really love, like, I really dream about having millions of qubits, which is crazy.
And the other way around, what's your quantum nightmare?
Not having those, having very little a qubit sometimes is very frustrating.
So imagine we get there and you have the first universal fault-tolerant quantum computer tomorrow. Who would you give it to?
Everybody. I would like to have everybody having access to it.
Okay. Well, thank
Even
you.
my mother.
Even your mother. Good. Well, that gave us, to stick with your favorite painter, a great impression about what you, Istelon and BoxCat, are doing. We get a lot of questions about use cases, and rendering images might not be world-changing, but it certainly makes the world a better place if we get to watch good animation pictures. So thank you very much. Thank you to our sponsors and co-moderators, Denise with Cambridge Quantum Computing, Tommaso with Entropica Labs. This concludes Season 2, Episode 6 of the weekly Quantum World Detangled. You are now detangled.